Hey guys, it's episode 10. You're amazing. Come on, let's get started. So guys, we ended this with exiting rooms and walking around our dungeons, and it's so cool. We got sounds. We're walking around the dungeons. We did miss one thing, but before we go any farther than this, I want to pull over my handy dandy, super awesome notepad, and let's look at things. And don't forget to get episode 10 from GitHub. If you haven't been keeping up and you want the up-to-date code, you can go to episode 10. It's on GitHub. I'll always share the links after this is over. Also, don't forget to subscribe, to like, to click the bell, to give me a comment. I love comments and feedback. I need feedback, guys. It'll help me get better and help me answer any questions you guys might have. So now that we're done with that, let's look at things left to do. We're getting kind of down to the nitty gritty, but there's so many things we could still do with this. I don't want to beat dead horses though. I kind of would love to just let you go, although I'm having a blast making these videos and seeing you guys do them, or seeing you guys do the work, or hearing about you guys doing the work. So it's pretty cool. But maybe we'll leave some of these to not do so you guys can finish them. Here are things we still have left to do though. First thing is when we exited the room last video, we saw that we were going past the traps message. So we got to fix that. We want to make a character info sheet. I'd like to be able in game to say, hey, what's my info? So I can see my hit points left. I can see how much gold I've accrued. I can see my stats. So we should make a info sheet or statistics option. Remember, we need this GUID feature, global universal ID, so that the player can't play the same adventure twice. Let me put little thingies. All right, and we got to create our character. We really, all we've done so far is have Conan. We should make a character creation mechanism. We need to make riddles and lock doors and try to get guys to unlock stuff or to figure out the riddles. And then cryptocurrency. We keep talking about putting cryptocurrency in here somewhere. Totally doesn't fit the theme, but I really want to jam in cryptocurrency somehow. And this will go at the bottom. At the very end, I'd love to have some way of every now and then, if they open a chest, we make a roll, and based upon a number, they might get to go out to the internet. That way I give you guys an idea. We would actually link up our console application with the internet, with maybe an API that you've created out there in the world. And maybe you've got some crypto wallets that someone could win. So if they open a chest and maybe we roll a random number generator, and if they get the right number, then maybe we make a call out to see if you currently have any wallets. I mean, you'd be in control of if you have wallets out there or not. So that's an idea. Is death permanent? Well, yes, I think it should be. I think that should be permanent. I think we should have, if Conan dies, he's done. He can never be played again. I mean, obviously someone can go into the JSON and fix that, but I like the idea of just, you're dead. And then maybe we have a graveyard option where they can go and they can see everyone who's died. Maybe we list them by levels, kind of like a hero's graveyard. That would be fun. And then, of course, one thing we have to do that's not optional is we have to do the final objective for the adventure. So remember, we have to work in how they can actually, just so we know that they finished the adventure, so everything's good, and they get all the hoopla, way to go, good job type of thing. So quite a list. We're still busy, so maybe we won't do all these. Maybe we'll just get the few things we've got to open chests still. These are the absolute things, right? We got to open chests, check for traps in chests. That's super important. And do riddles and lock doors. I feel like that's normal gameplay. So here we go. Here are the features we absolutely have to finish. Just the basic thing, the basic first iteration, I feel, are these. Here's iteration 1. We have to do this. Then we can start doing, more fun stuff. Create the. I feel like this should probably go up there too. Then we can. These are all the nice to haves. These are the have to haves, and these kind of go together. They're making the GUID and the final objective. That'll be kind of together. All right, so there we go. Let's get started and pick up where we left off. Traps. I want you guys to try to think for a second of how we're going to fix this trap. Let's run the game, and I'll show you the problem we have in case you forgot. So we start. Make sure I got a breakpoint. Yeah. So we're going to exit the room, right? So we start 0. All right. So we exit the room. We go through all this stuff. And now we're going to process trap messages, right? Boom, boom, boom. Oh, we were damaged. We took our, we're not dead yet, but we did take some hit point damage, and boom, boom. And now it goes to exit room. So we didn't see any of the trap information, right? And that's a problem. So that's where we're at. So we exit room and we go to process trap message and damage. Think for a second, if you would, how you would fix this problem. Well, here's our trap, process trap message and damage, clank, the damage, and then it just goes out, right? What will we do? Yes. Right here, we need to read line. We're just going to read line and make the person have to hit enter so they can read the stuff before we go to the trap room. Plus, if you're dead, we need to implement here, and I think we've got this first problem fixed. Let's go. Conan's going to go north. Let's make sure we get some stuff. There we go. Clank. A sound of metal falls into place. You tripped a poison trap. You were damaged for 2 hit points. You now have 2 pointsies. All right. And there you go. Perfect. There. Now we're in scare room. Good. All right. Done. All right. So I'm taking my little list here and I'm formatting it. Things that are done. That's done. That's done. These are nice to haves. Okay, so if there's a chest, we can do open chest or check for traps. So let's do that. I think we've already, if they click O, we're going to open chest. And we have not implemented this yet. So let's open the chest. To do that, we need to see what's inside of our chest. Let's look at our chest object real quick. Over to models and check our chest. We can, so chests are locked. There's traps, there's items, and there's gold. Perfect. All right. Let's first of all implement the easiest path, and that's just opening a chest. It's not locked and isn't trapped. So as we know in our traps, when we have no traps, we check to see if there's a trap. If it's not null, we do stuff, and then if it is null, which means there's no traps, we just return you find no traps. So let's pretend there's no traps and there's no locks. So if the chest dot locked, and we could say equals false, but we're not going to do that. We're going to use the exclamation point, which is like false, so opposite of true, and we can get rid of this. So this is a shorthand way of saying if the chest dot locked equals false, else console, else we're going to message handler, sorry.
Hey, Abby, hold on 1 second. Todd, are you talking to me?
Nope.
Okay. All right, go ahead.
Chest is locked. Would you like to attempt to unlock it? Perfect. We can remove the throw not implemented exception. Let's finish this else branch really fast. The chest is locked. Would you like to attempt to unlock it? So remember up here, which is how we do it. We read and then we find out what they wrote, and then we move on. So we can just come up here and grab this on line 144, and we should give the user some hint as to what we're looking for. So would you like to attempt to unlock it? Y or N. Right, and so var, yeah, player decision. This is good. Player decision, da-da-da. And then we're going to switch. We're going to switch on player decision. And we may put this into its own method, but right now we'll just handle it here real quick. Case. So we're going to say case y. Remember, we did it to lower, so we can test for lowercase. Case y. And here we'll throw non-implemented exception. I said throw, new, throw, idiot. So I don't care if they hate N or K or J. We'll do the default as we'll just return anything but Y. If they pick Y, they're going to try to. Ooh, and I forgot we can put a message in our not implemented exception to give us some hints. This is cool. We haven't implemented unlocking chests. I don't know why that had a capital. Beautiful. Now, when we get this exception, we know exactly what I think. Oh, we forgot to implement that. Okay, very cool. All right, if it's not locked, now they opened it. We can say, and now we can check if it's not trapped, right? So we say not chest dot. Actually, that won't be a true or a false. See, this will evaluate to a true or a false locked, but the trap inside of a chest. Where's our chest? Where's our chest? So a trap is actually a trap, right? Where the locked is a bool or a true or a false because it's a Boolean. Traps are actually a trap, so we're not going to say if is it true or false. We can't use this because that's not this is more of a Boolean thing. Is it true or is it false, or is it not? Not meaning false. So here we're saying if trap is not null, that means there isn't one. And I'm going to assume, and I could be wrong. Whoa, what the? Tab. I'm going to assume that if this is a trap, could we just use process track? Can we do the check traps? Where's our check traps? Control MO, remember that? Control MO to close everything. I just saw it, check for traps. No, see how we implemented that? We implemented that with a room. Man. We might want to refactor that so we can use it for chests or rooms. Give me a second. Okay, so first of all, they're not checking for traps. They just flung the chest open like an idiot. Hey, chest, woohoo! All right, so we're not checking for traps, but when they check for traps in the chest, we will refactor this method so that we're not sending in a room. We'll do all this superfluous stuff, room trap, all that stuff in the methods that we'll call this. All this stuff out in here that does trap bonuses, trap damage, all that kind of stuff. We will leave that so that we do not break the dry method. Another very important acronym in programming, if I haven't already mentioned it to you, is dry. Do not repeat yourself. If you're doing something twice in the same class, you're doing something wrong. You should refactor it so you don't have to. And we'll do that in just a minute. But let's go back to open chest. We opened chest. We didn't check for traps. We just flung the chest open. So look at this. Once again, we sent the room in on process trap messages and damage when we don't have to, because we don't want to send in the room. We want to send in the trap, not the room. So I'm going to refactor this, and I'm going to send the trap in instead. So we know there's a trap. We're doing the trap damage. We don't want the room because there's other types of traps. There's room traps. There's chest traps. That's what we don't want to do. So let's get rid of this. And yes, this will break earlier in our room when we go to use this. We should be able to, if we were to hit run, now we'll get an error because this is asking for something different, right? So we say, no, show us an error. Cannot convert room to trap, cannot convert room to trap. So we're doing this in two places. Here we just, instead, we want to send in the trap. Boom. Boom. Go to our output where our error list. We have our second one. So did you see that? Down here we have a lot of nice little windows. Our output tells us whether thing's built or not, and then our error list. And as I fixed that one error, it took it away. So now I can do this one. I can double click it, and it takes me right to the problem, right to the issue. And so I need to send in the trap. There we go. Now this should still be working. And now in our open chest method, if there is a trap and we just flown the chest open that we know, right? We can, first of all, we need to check and see if the trap was disarmed. So it may have been disarmed. Maybe we've already done the trap. Now we're opening the chest. So let's say chest. I keep wanting to write check. If chest.trap.disarmed, tripped or disarmed, right? And if it's not, because that's a Boolean, so we want to say if it's not tripped or disarmed, then we're going to process trap damage. And we send in the chest trap only. Beautiful. There's a perfect refactor that keeps us doing dry stuff. Do not repeat yourself, all that, right? Perfect. So what does character have? What do chests have? So what do treasures have? We have a list of items and we have gold. So we can check and we can say for gold, gold is easy. So our character has gold. Yep, how much gold does he have? So he has amount of gold, but now we're gonna add chest.gold. Now what is this again? This is an int. So an integer can never be null. If you're trying to add things using, I mean, there's certain times when you try to do things, and if it can be null, which literally means nothing, it will blow your program up. Okay, so you got to be careful when messing around with nulls or something that could be a null, that you're not concatenating with it or trying to use one of its children. You know how rooms have traps? Well, if I say room trap dot is disarmed, but I didn't check to see if the trap is null, and if the trap is null, is disarmed doesn't exist, kaboom, everything blows up. I hope that makes sense to you. So you got to check for null, but integers can never be null. It's a number. It can never be null. So even if we don't put anything here, as we probably didn't for Conan has 2 gold. If we didn't fill this in at all, and actually I will take this out and show you. Let's take that out. All right, so we didn't put anything in for gold. Watch what happens here in a second. As soon as I get this going, gold will be 0. Integers. Okay, so let me actually just show you this in the MSDN Microsoft guides, and I will put this link in the description below. There's actually 2 overarching big types out there, right? There's value types and there's reference types. All types are underneath these types. Value types are also called primitive types. It's kind of how they sit, where they live in the CPU, whether it be on the heap or the stack, and that's all computer science stuff. You don't have to know that right now. Just know that value types or primitive types can't be null in their form. There is a new implementation where you can say, hey, I want this to be null, and it puts a wrapper around it, but forget that for now. Just know integers, booleans, dates, shorts, which, you know, there's a bunch of number types you haven't dealt with yet, but integers cannot be null. Reference types can be. Strings can be null, all arrays, lists can be null, that type of thing. All that to say, we don't have to worry to do this. This cannot blow up. If gold is not in Conan, then it'll be a 0. It'll automatically be a 0. You'll see that here in a second. But what we do want to check, inventory. We want to make sure Conan's got inventory, right? So because maybe this is their first adventure, they have no inventory. Did we give him inventory? We sure didn't. See, this is gonna be perfect. I'm not gonna check for null here, and I'll show you how it doesn't blow up with gold because it's an integer, but how it does blow up with a list, which is a reference type, which is what he has, right? It's a list of items, inventory. So we're gonna take the inventory, we're gonna do add range. That is see how on the inventory class that's written for us, we have an add, which adds a single object to the list, but we also have an add range. Add range is what we're looking for. It adds the elements of a specified collection, so it adds a whole nother list. So we're not just adding one thing at a time, we're adding a whole nother list. So we're going to add range, and we're going to, you can see it tells us that this list is a list of I items, and so we better have another list of I items. We can't be adding a list of strings or something else. It needs to be a list of I items, obviously, to this list, which makes sense, right? And so the chest dot treasure should be a list of I items. Let's make sure the chests. So, you know, it's a list of item. This might be a problem. We know ourselves in here that that item actually implemented I item, but I think it would be better. It'd be better and more abstract if we weren't asking for a concrete implementation in here. This is an actual implementation of I item. I want to do that. That way it's going to let me, yeah. So I'm using the interface rather than the model. That way I might be able to pop in other different types of items in the future. I don't know if we'll ever have another. What other type of item could we have? Doesn't make sense. But all I know is I'm abstracting away. I'm getting rid of the concrete stuff and keeping everything abstract, which makes things more testable and more flexible and less coupled. You never want to couple things. So now we bona fidely have a list of I items. Perfect. But this will blow up because this guy is null, which means when I go to do this, it's going to be like kapoom. And this guy might be null. So we actually need to check that both are not null before we do it. But we're going to run it anyway and see what happens. All right, I'm going to take some damage probably. I don't care right now. Actually, let's stop it there so we can see if this worked with the room thing. So boom, it went through. We sent in the trap. We're no longer using the room. This should work just fine. Perfect, we're doing good. So bam, ooh, we only have one hit point left, ouch. Now that we saw that, let's get rid of that one. Now we have a chest. We can look for traps, we can open chest, and we can check the chest for traps. We're just gonna open, which is what we just wrote. Boom, here we go. So we got our chest. Chest locked is false, so this will work. Chest trap is null. Okay, you see what I did here? I was totally backwards. If the trap is not null, you guys probably saw this the whole time thinking, what a goof. What are you doing, dude? So yeah, I put these, I flipped these. This stuff should be going down here. This stuff should be coming up here. But this should still work. Even if it goes through, as long as we don't die, we should be able to open then, and then it's disarm. We'll try that here in a minute. So right, I got it backwards. If it's not null, we want to do trap stuff. If it is null, if it's null, which means it doesn't exist, we want to do all this stuff. Let's start again. Chest is not locked. There's no trap. Now, character. Remember, we changed Conan to have no gold, but if we look at his gold, 0. See? This is what I was saying. And so the gold is 5. Yeehaw. Now look, inventory is null. So when it goes to do this, it's going to say kaboom, exception thrown. And that's going to go kaboom. So we got to check both of these if they're not null. So let's do that really quick. Let's create a message, var chest message. This will be the default message. All right, so if you've been following along, what I did is I made a chest message that was going to have a default. So if nothing changes, this will be the same message. But then if we do have gold in the chest, then we're going to add it to our character, and we're going to report what they found. Yay. We're also going to say if chest.treasure is not equal to null. Okay, I'm thinking too hard into this. I was wanting to just be able to do it this way. Let's just implement this and then see if there's a better way to do this at the end. So I'll just stick that down there. So we'll just say message handler dot write right, and then we'll say message handler dot write. And here's the thing: we have to go through. We want to go through the items and list out what they found. So let's say message on write. You find. Let's get the count. Let's see how many items are in there. Let's do that. You find chest.treasure.count, because lists have count. You find 4 items in this chest. And now we're going to have to iterate through and they are, so let's do that, right? And they are and now we're going to want to iterate through our list and list them all out. And the easiest way to do that is a for each loop, which we've done time and time again. So I just did tab and it implements all the stuff. So we're going to call it, it called it item. That's perfect. Var item in our chest.treasure. Now we can say, that's an actual item in the treasure. Perfect. Before we do that, let's check for our null for our character. If character dot inventory is somehow equal to null, let's make one for him. So for some reason the character has no inventory, we're going to say character inventory equals new list item. There we go. That's all we gotta do. And now we're gonna go for each, and now we can add it to the dude's inventory. So we've just taken care of the inventory issue, and we've checked for the treasure issue, and now we can report out and add. So we can say for each item, we can say message handler dot write, and we want to use our bool with line, right? So that's cool. Oh, you know what? We never implemented this with interface members. So that's fine. Let's get rid of all these usings for now. Remove unnecessary usings. Let's clean that up. Let's go back. We won't decouple this at this point because I don't want to go into all that right now. We'll go back to an item, which that's not going to know where it's at. There it is. And now we'll get back. We'll get rid of the interfaces. Back up. Perfect. I'm going to close everything with this. Let's go back to here. All right, now we should see all the things that we need, right? So name. Yes. That needs to be a toString because that is an enum. It's not a string. So that's gonna name all the names out, and then down here we'll do the add range thing that we did a minute ago, right? So we'll say, now that we know we have a character inventory and we have treasure, we'll say character inventory dot add range chest dot treasure. And then here we can just say easily, just say if chest gold is greater than 0 and the chest.treasure is not equal to null, then we know we would have done something, right? So we'll just say message handler. And get rid of all that. That should be it. All right, let's check this out. Chest is not null. Gold is more than 0. So our gold of 0 should get, that should be up to 5, right? So there's that. Let's see, did we get that message? Woo, you find 5 gold. Your total gold is now 10. Huh. Oh, I'd already added 5 here, and then I added 5 here again. So that's a bug. Good job, Vance. Next, treasure is null, so we skip it, and that's it. And we're in an endless loop. Why is this? Probably because we haven't written room options. Because we want to write room options again, right? That's what we didn't do. Okay, a couple quick things. I forgot to reset the player decision to ask for the player decision again after we wrote the room options. That's why I just stayed in the crazy loop that we've gotten a few times. I'm not even sure. Remember how we did this whole while exit room equals false? I don't know if we even actually used that, but we'll go back and check that out a little bit. Another thing I thought about is once we clear out the treasure, it needs to be gone for good from the chest. So since we add this gold to the character's gold, we don't want to do that again over here. We just want to say character's gold to report out how much gold we have now. But what we also want to do is now make the chest gold 0 because it's gone. Chest gold equals 0. It's empty, right? And then the treasure, the same thing. After we picked up all the treasure, we want to say chest.treasure equals new list. And there we go. That way it's a brand new empty list. So that's cleared out so that we don't keep opening the same treasure over and over again and getting rich. The magic chest of never-ending gold. That would be awesome, actually. All right, let's see inventory system work. So we get going. We mark. All right. All right, we're iterating over treasure. We got 2 treasures, yes. Which means it converted right. We got a rope that looks fancy. No value, no number. And what's our second one? The Duke's Chalice. Holy symbol, objective number 1, 2, 3. I like that we're doing this so we don't have to see if this is the Duke's Chalice by looking at a string. This will be nice when we go to do that for the final objective. And so boom, we're gonna write these 2 out. And then we're gonna add it. And so now there's no treasure left. That's good. And what does Conan have? Let's see what Conan has. Conan's got inventory. He's got 2 things in his inventory. Fancy. Got a fancy rope. And he's got a holy symbol that's the Duke's Chalice. Love it. Woot. All right, so it lists it out. Woot. You find 0 gold. Your total gold is now 5. That's weird. You find 2 items. I think I know why that did it. You find 2 items in this chest, and they are a rope and a holy symbol, and then we need a new line. Why do you guys think that did what it did with the 0? You guys catching on already? Well, check this out. When we reported it down here, you find blank gold. Well, we already zeroed it out. So let's move this down below the message so that we can tell how much is in the chest, and then we can zero it out. That should fix that problem. And let's write a line / new line. And I don't love that, but it's something, it'll work. That should make our message handler look right. Do the character inventory, good. Let's lock the chest, y'all, and figure that out. Okay, guys, I'm about to do something I haven't done yet. I had to stop the video, figure a bunch of stuff out, and go from there because we're getting into some complicated stuff, and I couldn't just do it on the fly. But in the meantime, so in a second, I'm gonna start a new video where I jump ahead, and then I go over all the code that I wrote. But what I don't cover in that is what I did to the JSON. So I want to go over what we did in the JSON. Compare your JSON, pull up your initial JSON and compare it with mine because it's going to be important. What we did is we have 4 rooms right now, right? We have room 1, 2, 3, and 4. That makes 4 rooms. And the way it's laid out is something like this. Here's room 2, here's room 1, and here's long hallway in the east, and then there's our room 4. And so what we did in here, we have a chest that has a key. This has a key here that will open up the chest over here. And in this chest, it has the key that opens up this chest to the Duke's Chalice. Also, we're going to lock the door right here. So here's the map. That is the best map I've ever seen. And I wanted you to get an idea of that. So let's check the JSON. So we got room number 1, description, trap, nothing's changed there. But anyway, we have, we put a key in there. It's objective number 2, which is going to be important. We're going to check objective numbers in a minute, and no gold value. So there's your treasure for room 1. It now has a treasure chest, which it probably didn't before. Exits are the same. Room 2, we have a chest that now has a lock because we created a lock, and I will go over that here in a second. So write this down, lock true, key number 22. So we're looking for objective number 22. This is objective number 2. Remember I said it opens number 4. And then it's got gold. And in it, here's our treasure, which we already had. And then there's our exits. Now room number 3 is the long hallway to the east. On the exit, we're going to create another lock. So write lock. Locked is true, and key number is 2. So yes, I'm sorry, I messed up. Key number 2 that you get in this initial chest will open up this door eventually. All right, so that leads to room number 4, which will have a chest. So in here, here's the chest, and the treasure has key, which is key number 22, which means the player has to go back to room number 2 and use that key to get the Duke's Chalice, and that's the game. So that's it for the JSON. Make sure you get all that before you go to the next section. Okay, guys, I had to take a step back here and look at this. As I said, or maybe I've cut that part out, we've got a real problem with, we're just building a lot of stuff in a single thing and it's not testable. We need to pull it all out into its own services so we can run unit tests on it because there's so much logic. Whenever you have logical branches, you need unit tests to test those logical branches. We don't have that, and I'm not going to do that right now. I'm going to just keep forging forward. You'll see how cumbersome it gets when you want to test all the things and you don't have it split into proper logical divisions and services so you can run unit tests. So that's one of the issues. But I'm forging forward to get us into a place where we're having fun with the game, and it's fun. But so I made a bunch of videos of me on the fly trying to get this open chest thing and get this unlock thing going. And I had to finally stop the videos and just work it out. Sometimes it's not easy to code on the fly while you're making videos. So I did a bunch of coding while you were not around. So we're going to go over that here real quick. Now we have a problem right here. Back to open chest. We're going to go to open chest, and if there's a trap, we do trap damage. One thing we need to make we don't do in trap damage in process trap message is we don't change the traps. So we need to say chest.trap has now been tripped or disarmed equals true. That way we don't go through that every single time. That was one issue I saw that we were having. So if you've got this, make sure you do this here. We added a message handler saying, hey, you opened the chest, because we were just kind of explaining what happened. That's just eye candy, makes it a little better. So again, I'm not sure where we were at in the video, so I'm going to go through all this really, really quickly. So make sure that you got everything. So character gold plus or minus equals chest gold. That way we automatically give our chest gold to our character. And then we report out that you found this much gold in the chest. And then we report how much character gold there is now. And then we empty the chest out. This was a problem. We check if the treasure does not equal null and if there's a count of 0, because the treasure might be an empty list. And so this will come in as not being null, but there's no treasure. So you don't want to go through this. So as long as there's pieces of treasure in the chest, we're going to report out what they are. We're going to report them all out. And if our inventory has not been instantiated in our JSON data yet, we're going to make a new list so that it doesn't blow up because it's a reference object, not a value object. So it can be null, and we don't want to just look at it if it's null and try to get into it if it's null, because it will blow up. Then we go through, report out what each piece is in the chest, and then we add all of that to the character's inventory, and then we make the treasure an empty list so that the chest is now empty. And if the chest gold is 0 or treasure equals null or the count equals 0, then we say, hey, the chest is empty. Perfect. That's if it's not locked. If it is locked, we created a method called try unlock, and this is going to be able to be used by both chests and doors. We made it generic, where we send in the character and we send in a lock. Okay, it's asking for a lock, and it's asking for it by reference. This is a new thing, so we are sending it in by reference, which means sorry about my throat. I'm in Tennessee, man, and the weather this morning is terrible. It's so many allergies. When you send in an argument into a method, say, and typically into a method, you're not sending in the actual object. You're just giving it like a copy to the method to use. So anything inside a method that does stuff upon the argument you send in doesn't affect the real thing in the real world, unless you send in ref. There's also a keyword called out, which pretty much does the same thing with minor differences. I'm not going to go into that. But when you add the ref by reference keyword, and you'll see down here, I'm saying, hey, I want a lock by reference. When you're saying I want a lock by reference, which we made a lock object, which we had to, because we needed more than just is locked. We wanted several things. We wanted the key number to know if the character is carrying the right key. We wanted to know if the lock has been attempted yet, and we want to know if it's still locked. And so in here, we want to affect the actual real lock out here in the real world. So I needed to do that because I also wanted to return bool. I wanted to return whether the thing was unlocked so that I could say, hey, you can see here I'm saying if it's unlocked, then we're going to open the chest again. If it's not, we're going to go through all the options. We're just going to fall through and go through the options. So this is what you want to write. If try unlock, character, ref, open chest, da-da-da. And here's the method. This is a big method. I really hate this. Needs to be a testable method. It needs to be in its own lock service. But once again, we're not going to go down that alley right now. We're gonna get to a playable game first, and then we can do some of the mundane stuff, the important mundane stuff, if you want to maintain this game any longer. So we'll write a private method that returns a bool. We're going to call try unlock, send in a character, send in a lock by reference. All right, so we want to be doing certain options while we have options available. Once we tell our loop, this is that while loop we've done before, that we have no more options, it will fall through and it will return false if it hasn't already returned. We're going to bring in some dice. We need some dice for this, yay. And we're going to call the local lock that we can actually play with. I'll tell you why we have to do this here in a second. So the user sent in a lock. We're going to say, hey, has the lock been attempted? Once it's been attempted, meaning we've either tried to pick it or we've tried to bash it. The way our game works, once someone's tried to bash it or pick it once, you get one chance at that, and then you don't get any more chances at that. So if it's not been attempted, then we can say, hey, You know what we need in here before we do all this? I'm just realizing, let's just make sure that the user didn't send in a lock that's unlocked. We're not checking anywhere if it's been unlocked. So let's just make sure, because users will make mistakes. So we're going to say, we'll put this at the very top. Here's a very basic but important principle in programming. Return early, return often. If we can jump out of a method right off the bat, if we can make a determination via some logical reason that we don't want to be in the method, do that first and get out. It'll make the program faster. So this is something we need to make sure. So if the lock, we're going to say if the lock dot locked, and that's not what we're looking for. We're looking for if it's unlocked. So if we're saying there's our not, if it's not locked, then we're out of here. And we can do it all on a single line. It's super easy. Boom. So if for some reason someone called this method and sent us in a lock that wasn't locked, we're getting out of there. Perfect. Return early, return often. Great. All right. So now we're down here. We know it's locked, and we know it hasn't been attempted. We're going to say, hey, it's locked. Would you like to attempt to unlock it? We're going to give them key, lock, bash, or walk away. And so we're going to do a switch. Just write all this stuff down, guys, and I will try to make sure that it's all readable for you. We're going to do a switch on the player decision, which we do, right? We get the player decision every time that we're in the loop. We're looking for a K. We're doing to lower, so we can do lowercase here. And then here is why I had to do a local lock, because when you're using your Lambda expressions and your link, for some reason it doesn't like by reference. I don't know why. I had to make a local copy. And I made the local copy just to check the key number. So what we're saying here is if the character's inventory, if the character has any keys in their inventory, this checks all the pieces of the inventory, and we're looking for a type of key. So right now it's looping through the character's inventory and say, hey, do you have a key? Okay. If you have a key, if that key's objective number, and that's going to be, what we call the key number, is the local lock's key number. If those are equal, if it's not equal to null, that means the person actually has the right key. So we're going to say, hey, you have the right key. It unlocks the lock, which basically we're simulating a user trying all their keys, and they found the right lock, and they just unlocked it. And this is where we actually changed. We changed the lock in the real world back up here by using reference. We used lock, and it was easy. So you might be asking yourself, well, why couldn't you have just said if try unlock equals, true, then that means you unlocked it, and you can say up here that the lock is unlocked, and you don't have to do it by reference. That's a good question. The reason is I have to do three things. I'm not only changing the locked to false, I'm also changing attempted once they attempt it. So there's three things that I'm doing in this method, which is a code smell. There's probably something better I could do here. When you've got a method doing sending back a Boolean and a lock and doing multiple things. It's kind of a code smell. It's kind of a, hey, how can we do this better? So we know there's a code smell in this method, and we might examine it deeper later on. But for now, we return true. You have unlocked it. Otherwise, you don't have the right key. And so I didn't say that there's no more options, which means it's going to loop through again. It's going to give you the options again. If the person says they want a lockpick, we're going to look through. Here's our Lambda stuff. We're going to look through their inventory. If they don't have lockpicks, then if it equals null, meaning the user doesn't have a lockpick in their inventory, we're going to say you don't have lockpicks, drop out, break. The break means we drop out. We go through again. If they do have lockpicks, let's find out the lockpick bonus. We're going to give them a bonus for their dexterity. So 0 plus whatever their dexterity is. Then we're going to say, are they a thief? So we're going to give them an extra 2 points for being a thief. So you might have 4 to your lockpick roll. And we just decided an arbitrary number of 12 to be, that's what you need to pick locks. Don't know why. Sounds good. It's a little higher than 50%. So we use our dice roll. We throw in a 20-sided dice, and we add our lockpick bonus, and we have our pick roll. If you get it above 12, then you've picked the lock. Otherwise, snap. The lock doesn't budge. Your lockpick roll was blah, and you need a 12, so we'll tell the person what it is, which we also do up here. And we say right here, we attempted equals true, and we break out. Now, up here, it's going to go to the else up here. But let's keep going. We've got one more option. We have B. We have a bash, right? So bash bonus is strength. Now we're not doing dexterity. We're doing strength. And if you're a fighter, we're going to say you're better at smashing because Hulk smash, right? Same thing. This is very similar, very, very similar code. I almost did has options equals false, but we know we're going to do that. That'll happen down here in the else because they may have bashed it, but they might also want to try a key or they might want to walk away. So let's get rid of that. Oh, this is wrong. So yeah, I need to unlock the lock. No, I'm sorry. I'm looking at the wrong thing. Did I do that up here? Yeah, I didn't do it. Now this is very similar code. We figure out a way to put this into a method that brings in, you know, the ability and the class, and then we determine and maybe the target number, so that we're not repeating ourselves. But again, we're going for it. On the bash roll, we picked 16. Doing the same thing pretty much. We're just picking the 16. We're saying, boom, you must do strength. You smash it in, boom, boom, boom. Otherwise, ouch, lock didn't budge, da, 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 and we are out. Now we've attempted, and we don't have, so once we've attempted, we decided that design decision, if you've attempted the lock with a bash or a lock pick, we're going to go ahead and just check your keys for you to make sure you don't have it. Maybe you do have the right key and you just forgot to look. So the user, we look through. If it's not equal to null, which means the person has the right key in their inventory, we say, hey, you got the right key, bro. You're good, and we return false. If they have bashed it and they do not have the right key, that's the worst case scenario. We're gonna say you cannot try or bash this or pick this lock again. You cannot try to bash or pick this lock again, and you don't currently have the key. Get out. And so they're gonna have to go find the key. Basically, that's their only option. So that actually works well with our game. We've got key in room 1. You'll see we got a key in room 1. This unlocks the chest in room 4. Room 2 needs key number 22, which is in room 4. So you can imagine if we're in room 1, we have to go to room 4 to get key to 22. So let's play it. Let's see it work. All right, we're going to open the chest, and let's get rid of these break stops. All right, we find one key. Great. Let's go north. Now we're in room 2. We're going to try to open the chest. Locked. Would you like to attempt to unlock it? Yeah, let's use keys. We don't have a key for this chest, right? Because we have key number 2. We need key 22. Let's try to lockpick. We don't have lockpicks. Great, that works well. See, now here's where I wish I had tests, because I want to do with lockpicks, without lockpicks. With bash, bash successful, bash not successful. But I digress. I'll stop talking about it. I'm mad at myself that we're here. That's okay. It's what I wanted to do. So let's try to bash. All right, let's check out our bash bonus. So we are a fighter. No, I'm sorry. I'm over. Whew. Conan's a thief, so I won't get a bonus of 2. But Conan does have a bonus of 1. So right now we have a 1 for our bonus. We roll a 2, and with our bash bonus, man, we must have rolled a 1. Brutal. So we're gonna get this bad failure result. Blah blah blah. Boom. Boom. And now we have options still, but we've attempted it. So now we're gonna check, and we have reached the worst case scenario. Let's see what that looks like. Ouch, the lock doesn't budge. Your bash roll was a 2 and you needed a 16. Ha. You cannot try to bash or pick this lock again, and you don't currently have a key. So we have to go south. That's all we can do. We could look for traps, but we're not worried about that. Okay, I gotta see. I think we have an issue with our traps. Does room number 2 have a trap? Yes, it does. Okay, so that's okay. But I think we're not disarming the traps once we trip them. Let's check that. So, all right, back to room 1. Now we have to go east. Yeah, see, we tripped that again. That should have already been tripped. That's done. So we got to fix that. Now we are in a long hallway. We want to go into the east room. Now the door is locked, and we're going to put this door lock on before we finish for the day. Try unlock, but we'll do that in a second. Open chest. Another trap. Okay, so we've tripped the trap. We know we have a trap. What's up with this too? We also have an issue with, well, that's misspelled, and our hit points are not doing what it should be. I wonder if we're at -3 here because I didn't do death. We'll figure that out. It's not a big deal. Let's open the chest again. All right, well, now we tripped the trap. We can open the chest. You open the chest, you find 2 items. We found food, and we found a key. Right, so now we can go back west, back north, and open the chest, and we should have... You tried bashing and picking to no avail, but you had the right key unlocked. Woohoo! 5 gold, and the rope, and the holy symbol. So that's going to be the Duke's Chalet. So, all right, we can figure out now how to do final objective in it. Well, actually in a later date. Let's get this door locked. We did lock the door to room 3, correct? Locked. Yep, and it needs key number 2. Oh, okay, the chest doesn't need key number 2. This door needs key number 2. All right. And here's our hit point issue. We were just reporting the hit points of what it would be, but we weren't actually taking it away from the real character. So that's silly. Let's character minus equal, character dot hit points minus equals trap damage. And then we can just, now we're actually taking that away from the character. So there, now we're going to get into death stuff. Okay, and so here's the issue. So upon exit room, we are, if the trap has not been tripped or disarmed, then we're going to do this stuff. So, but what we weren't doing is then changing room, trap, tripped or disarmed. Because now you've left the room and you've tripped or disarmed it, right? There's no way that we can process trap damage. Yeah. If we say process trap damage, you're getting hit with it because you didn't try to do anything and you walked right over it. But then we need to set it to true. So that's our problem. Let's double check that real quick on the damage, and then we'll get to unlocking the door. All right, we're gonna go north, which means we now have 1 hit point. Cool. Now we can go south. Uh-oh. And you're dead. Whatever. We don't care. You're dead. It's fine. And now we can go north again. And there should be no... Yeah, right? So, no more traps. Good. That's it. We're fixed there. Okay, guys. Let's go to exit room method, because this is where we want to check for a lock, right? And at the very bottom, we would normally be processing a room. This is where we're going to do our checks for the lock, okay? Now, you can see this. I went ahead and did this already. You can copy this, but let me explain what we're doing. So we're checking, and we're doing a complicated if. It's not complicated, but it might look at first. So when you want to do like 2 things together, kind of like in mathematics, you put them together in parentheses, right? Check this first is what you're saying. Check this first, and then check the other side. So the 2 things we want to check is if the lock is not equal to null, because if it's null, we don't want to try and check if it's locked or it'll blow up. And then we check if it's locked. So if it does have a lock on it and it's not locked, then what this will do is this will just jump out. Okay, if the lock is null, first thing it will do, if the lock is null, is it will jump out. It'll say, nope, it's null, and we'll go to the room processor because it doesn't even have a lock on the door doesn't even have a lock on it. If it does, it'll say, okay, well, let's check this. And is it not locked? Oh, it's not locked. It does have a lock, but it's not locked. So let's jump out. So if both of those are false, then we're going to the second part, which is or. So we're saying if this is, either one of these is right, or, and then we'll do our try unlock. And you might notice I took out character from try unlock method. I just realized character is, it's already a class variable up here. It's outside of everything. I don't know why I was thinking we had to pass it around. Remember, we made this a couple, maybe it was the last time or the time before, we put him as a whole class variable. So he exists, or she exists, outside of all the methods. So we don't have to send him in. That was dumb. And remember, we wrote this pick lock earlier, or I might have deleted that video. But anyway, we don't need it because we're doing try unlock. So basically we're saying if any of these three things happen, then we're going to do the room processor. If not, we're going to write, hey, you can't proceed to this door at this time. You'll need to find the key, because if this comes back false, then they've tried all options. That's not necessarily true with the walk away, though. They could just walk away and want to try it later. So we'll just have to say you either cannot proceed or you're walking away from this locked door. Either way, maybe they need to find the key. So maybe find the key. Give them a hint. That's what they need to do. All right, I like that. Okay, and as I was running through this, I also found out that character inventory is null in here, and it blows up when I send it in this way. When I'm doing it through the open chest, remember when we opened chest, we went ahead and instantiated it in case it wasn't null. Where's that at? So right here we said, yeah, boom. I didn't like this when I wrote it. I think this was dumb. And so I was trying to think of maybe in the start game when we first, let's get rid of this. So get rid of character inventory. And creating that in open chest. And I thought maybe in start game, when we actually load the dude, we load the character, and then maybe in here we make sure all this stuff is, you know, real in load character, and then we instantiate things that shouldn't be there. And then I realized, you know what? If his inventory is not null, that's a problem. That's a broken person. When we're creating characters, you need to create an inventory. We're going to put the onus on the person that creates the character, which will be us, because we're going to have create character thing anyway. So instead of going through all the places and making sure inventory exists, we're going to assume it exists, and if it doesn't, we're going to blow up. So what that means is we need to go to open up Conan JSON in your bin under your adventures, your characters, and now at the bottom we're going to do a comma, and we're just going to make an inventory. It can be blank. Sorry, quote, quote, colon, and it's a list, so we'll just do that. It's an empty list. All right, that should fix things. Now it should always be an empty list. So let's run the game. All right, we'll go east. We got hit, that's fine. We'll go east, locked. Would you like to attempt to unlock it? Yeah, let's do a key. So now we should have inventory. See, we have an inventory. It's an empty inventory, but we have an inventory. We should never not have it. You know, that just didn't make sense anyway. So, all right, cool. Let's get rid of that. You do not have a key for this chest. Let's try the lockpick. Oh my gosh. You don't have lockpicks. Well, then let's bash. Woohoo-wee! Okay, refactored a couple things, guys, so we didn't get that never-ending loop. That was cool. Going back to try unlock, you might notice I'm taking the ref out. I just realized that was stupid, because we have the lock belongs to the door or the chest, which belongs to the room, which belongs to the adventure. The adventure is a class variable, just like character. I totally forgot we had both of those. So we are manipulating, we're not just manipulating stuff inside of the method, we're manipulating the entire game adventure. So we're cool, we don't need the ref, but it's good that you learned about it by ref. So now as far as try unlock, what was happening is we were processing it, and then we were going, we just had a loop. So we're gonna do it, we're gonna do an else. We're gonna take out the statement we had a minute ago. It was unnecessary, and we're gonna do an else where we send in the room we're in as opposed to the new room. So if you can't get through the door, we're going to process this room again. But one other thing I did is I went back to my iMessage handler, and I added a new method called write read. That way we could write a message and make sure that the line is read so that it stops. If we just write and then go to the next thing, in here what it was doing is it was going straight to the room processor, and you'd never see the messages about the the lock. So write go to your iMessage handler and utilities interfaces and add this method, public void write read, that takes a message. So we're going to do both a write line and a read line in here. Write a message on a line and then read the line. Let's make sure we read the line so we know we're doing a read line and not read. And remember your XML comments, well, you just do 3. If I didn't, so let's say I wrote this, I didn't have these. I can just put my cursor right above the method and do 3, and boom, it gives me that message, or it gives me the parameter that I'm sending in, and then I can write the summary. But I've already done it, so I'm just going to do that one. Then I'm going to go to my console message handler, which is my implementation of the iMessage handler, so in the utilities folder, and I'm going to implement write read, which takes a message, so it'll write the line and it will read line. This will just make it easier. Whenever we want to write a line but not go to the next thing, we do write read instead of just write. Very cool. So down here, whenever I write something that I want people to make sure they read, I'm going to change it to a write read. Write read, you have the key. So as opposed to, because I know this is going to finish and get out, I don't want the person that called this going to the next thing until the user has read this. Same thing down here. You got the lock open. I copied that and pasted that. That's wrong. Your dexterous hands. Oh, that's probably misspelled. Click that lock open. Yeah, baby. Same thing if you don't get it. Again, bashing, not bashing, and then your final. So I did the write read several times. All right, and that should be all we need to get through this portion of code. Let's see, let's run this. We should now have locks and door. We have chests and doors that are locked that we just fixed. So I'm gonna go to the east without the key. Got hit, that's all right. I'm gonna go to the east. Boom, it's locked. Would you like to, yeah, let's try the key. Nope, let's try the L. Nope, let's try the B. I rolled a 5, I didn't get through, great. So there we go. Here's our write read. You cannot try or bash this lock again, and you do not currently have a key. In other words, get lost, pal. And so I hit enter, and it rewrites the rooms. I can try to go east again. I cannot, You don't have a key. Get lost, pal. Fine, I can go back west. I'm gonna go north. We didn't get hit by the trap. I'm gonna open this chest. I'm gonna bash it open. Oh, that's a problem. So we didn't get through it because it has to be above. So yeah, we'll fix that message. But we did make that. That's fine. Can't do it. So now I'm going to go back south. I'm kind of lost, right? Oh, yeah. Oh, and we're dead. That's okay. We're going to go as a ghost. I'm kind of stuck, ain't I? But I'm not. I'm not stuck because I can open this chest here in room 1. And now I have key number 22 or 2. I don't know. Now I can go back east. Now I can go back east. And look at that. You tried bashing or picking to no avail, but you had the right key unlocked. Boom. Now we're in room 4. Yes. We're playing a game. Open. All right. We have -2 hit points. We're really dead. Who cares? We're not worrying about that right now. I'm going to open. I now found the food, the key. Now back west. Now back west. Now north. Now open. We have the right key. And there we go. Game over. Guys, this has been I don't know how long this video is going to end up being, but you've done a ton of things. You learned about value types, reference types, sending arguments in by reference, even though we didn't end up using that. We learned how when you start putting a ton of stuff in a single method, what a mess it makes and how hard it is to test. So that's something we'll probably fix soon. But yeah. Great job, guys. We're now moving around. Now we can start doing, we can check for final objective next time. We're going to start putting monsters in. We're going to start creating. This thing is really turning out. It's awesome. We're going to have to do some cleanup soon and make things a little more testable. So that might be the next lesson. But anyway, great job, guys. You're awesome. Sub, like, love you. Peace. Phew.